folks, let's take a look at number 6. A boat costs $15,500 and decreases in value by 10% per year. How much will the boat be worth after 5 years? So if you're decreasing proportionally to yourself year over year, that's going to be exponential decay. All right, and your initial value was $15,500. So what I can read off of this is that I have some sort of exponential model. My initial cost, right, when time was 0, my boat was worth $15,500, which is a great ordered pair to have because I automatically get my A value, my initial value, right? So this is going to tell me here that A is $15,500. And then I'm going to think about this. If I'm decreasing and I'm proportional, right? My growth is proportional to my previous value. First of all, because it's decay, right? Because it's decreasing in value, we know B is going to be less than 1. All right? If your B was greater than 1, your boat would be increasing in value. If B was actually equal to 1, then your boat would stay the same, right? It would be worth the same amount year over year, but because it's decreasing, I know my exponential base has got to be less than 1, and we're starting from 1 and we're losing 10% per year. So that tells me my base is 0.90. So how this informs my decision is that I know f of x is equal to 15,500, my initial amount, and then I only retain 90% of that value from 1 year to the next, right? So each year I lose 10%, or another way of saying that is I only keep 90% of the original value. And I want to know how much is it worth after 5 years. So let's plug in f of 5. We're going to get 15,500 times 0.9 to the 5th. I'm going to head over to my calculator. Let me pull this up, and we're just going to see what that number is. So I'm going to do 15,500 times 0.9 to the 5th, and it looks like I have $9,152, excuse me, and about 60 cents, right? So if I take a look at that, the closest answer in A through D is option A. So I think the key part of this is recognizing that if you decrease by a rate proportional to yourself or increase at a rate proportional to yourself, you have exponential growth or decay, and you want to use that function as your model. All right, thanks so much. Bye.